then I'm going to have Azhar step up and talk a little bit about this thing called Edge.
So are you able to see my slides?
Absolutely. It looks.
And is the audio okay?
It's perfect.
All right, sounds good. So thank you very much, Diane and team. And so what we'll do in this session, in the next 20 minutes or so, is go through what does Edge mean and what does will containers mean in the context of Edge. So first of all, some definitions. We've seen various definitions of Edge. Edge is certainly the next infrastructure paradigm for delivering application services closer to the subscriber. And Edge allows efficient processing and delivery of time-sensitive data. People have used different other definitions as well, which is some geographic distribution of compute nodes, distributed computing paradigms, largely performed in distributed devices, etc. But Edge is independent, Edge is elastic, Edge is massive scale. Edge must be automated to meet that scale characteristic and those requirements and resilience, and be built using public, private, or hybrid, footprints with respect to cloud. Now, there's a lot to be said on just one slide in terms of what is Edge, what does Edge mean. One way to look at it is it's about building, ultra reliable experiences for people and, objects when it matters and where it matters. So then many times people struggle with Edge is customer edge, Edge is provider edge, Edge is, somewhere in between. Edge can be anything that sits between the subscriber and the provider core or provider data center. And if you take that broad definition of Edge, then automatically it will, you'll start to look at how do you solve different application challenges, how do you solve different deployment challenges, how do you solve different network challenges in the context of Edge, because then the footprints will vary, the sizes will vary, the deployment matters and contexts will vary. So let's start there. Now, we know in a telco space, typically a provider network can be classified or subclassified into many different tiers. Not all these tiers apply to every single provider in the world, because geographically some of these tiers are merged, and in smaller countries and in countries like US and Canada and Australia, you might have actually much more enhanced set of tiers. But certainly there is the access network, access aggregation network, there's a termination infrastructure, there is the last mile copper fixed wireless in terms of the wireless side of the business, or the copper cable, GPON, optical stuff. And then there is the customer CPE, whether it's a residential CPE or a business CPE, and then the actual customer network itself. If you look at that tiering or that categorization model, I mean, this is a work that was done between me and Pazi, and full credit to Pazi for actually coming up with this kind of a tiering model. And it then allows us to segment what is applicable in each one of these tiers. And then once you understand what is applicable in each one of these tiers, then you can understand the type of applications, the type of network functions, the type of capabilities that are required at those tiers, and then try to solve the problem of what is required from a infrastructure perspective, what is required from a networking perspective, what is required from a containers perspective, and so on and so forth. So you can keep double clicking into each level and then define that level of detailed set of requirements. I mean, everybody talks about Edge. I mean, here's an example of a slide that was done by China Mobile at the VCO keynote presentation in Amsterdam. And if you look at this in terms of the deployment model from national district level data center down to the base station, and this was because this is China Mobile, it's talking about radio infrastructure, the number of servers that they need to deploy this whole virtualized RAN with edge compute is about 1.25 million servers in terms of number of sites, number of locations, and then multiply each location by the total number that they need in about 2025. This is their estimates. And the distances that these reside from the base station or from the user, and the latency requirements and all of those. I mean, we ended up actually, again, credit to my friend Pazi here for actually coming up and taking pains to catalog all of these details. And the important point here is what I really want to show through this slide is not necessarily to dig up why or what, but to tell you that regardless of which way you cut it, it's going to be large. I mean, if you take this number and apply it to a number of cell sites, a number of locations, or number of points for AT&T or Verizon here, that still is a pretty large number. That still is, 200,000, 300,000, whatever that number is. Here it turned out to be more than 1.25 million in terms of the total number of servers that are required. But what's important in that context of scale is when you have those locations deployed with compute infrastructure, then functionality from the core data center, from the regional data center, starts to migrate towards those locations. When that functionality starts to migrate because you're providing better experiences, remember we started with a definition of edge is about providing better experiences. When you start to provide those better experiences, when that functionality starts to migrate towards that edge, then you need at that edge infrastructure or that edge location all types of capabilities, ability to manage virtual machines, ability to manage containers, ability to provide an assurance framework. You need a view of where those workloads are placed, how they are placed, what's your assurance framework, what's the overlay networking control or underlay networking control for all of those. Now, you just saw a presentation from Intel a moment ago about, what are some of the networking challenges specifically and how, Red Hat and Intel are working together to solve some of those networking challenges. There is, more than also networking challenges. We also need things like visibility into the nodes in terms of how do you place functionality, how do you distribute functionality, how do you manage storage in those contexts. So this is a massive challenge. Scale brings a massive challenge with it, and with that, the workloads, the different types of workloads, whether it's virtual machines or containers, need to be able to address all of those things. Edge computing, generally service category scenarios, if you actually broadly look at that, there are various different types in terms of how you can categorize or divide. There's the IoT application side, there's the network performance application side, there's the enterprise connectivity side, there's third-party network peering and hosting capability, there's customer-oriented residential or mobile types of services, or operator services, which is the deployment of base stations or VPNs or cache or CDN type of deployment. And regardless of which one of these, you take the number of locations and then multiply that by the size of those, requirement at each one of those locations, you're really, really talking a massive infrastructure. Now, when you have that, when functionality starts to migrate, whether that functionality that was in core data center running in Kubernetes or running in OpenStack and virtual machines, now has to be able to run at that same edge location and be able to be managed with a single pane of glass across both of those locations. So just putting out there in terms of the scale size and putting out there in terms of the complexity in terms of how you manage. So that brings me to, okay, so what are those use cases that are being deployed at edge? What are people considering? So if you take a pure telco view, from a telco standpoint, a telco delivers enterprise, residential, or mobile types of services. So those services are being terminated today on a central office. We have now a central office blueprint based on OpenStack. That central office blueprint now needs to convert it to be a container blueprint as well, instead of OpenStack, or maybe both, because you'll now have some of those network functions moving into containers. Then when you deploy just pure edge compute for other traditional applications, IT applications that are co-resident with these network functions, then those are running in microservices and containers, and so you need to be able to operate those. In the mobile case, for example, you have this vRAN, virtualized RAN. Now that virtualized RAN is becoming containerized RAN. So you're taking those RAN application and running them in containers. And I have actually a couple of slides later on to explain a little bit on that in terms of what's going on there. Then there are other interesting areas such as video optimization that needs to happen locally in that edge compute location. Then you have specialized deployment models such as stadiums or venues or big public venues. And then the technology itself is moving from an NG core perspective to containers, and we'll actually look at some of that in a little bit of detail. You can also take things like in the IoT space, you know, analytics is a thing that keeps coming up every time when we talk about IoT. And edge compute deployment is almost necessary to provide timely feedback into those sensors and devices that are autonomous, that are operating independently. Otherwise, the round trip delay times and then the compute processing time at a centralized data center is probably not sufficient, in terms of how quickly you need to take action in those type of situations. Then there are traditional telco services, which is your specific, CPE, managed CPE, VNF as a service, and so on. Today, some of these are delivered using dedicated devices, managed CPE stuff. Tomorrow, or pretty quickly, moving to a virtualized model, and pretty quickly we'll move to a containerized model as well. What you will see is, again, more in the word that I want to use is extensive thinking that's being put together by telcos to say, how should I go about transforming my existing set of services into this new model? And how do I go about deploying those? Again, we can talk about each one of these line items for a very long time. But what I want to give you through this particular list is a mix. The mix that's being deployed at edge compute layer is both a set of network functions and a set of traditional applications, the IT applications, that will run on edge, which means then whatever was typically running in a centralized data center now needs to be running at the edge, whether that applies to virtual machine context or or it also applies to the container context. Now we'll just take a quick drill down into two areas, 5G and 5G, because somebody brought up 5G here on the topic. I think it's relevant to take a quick drill down. 5G is seen as an enabler technology for new use cases. It's also seen as a leveling the playing field between incumbents and new entrants into the market. There are a lot of, you wouldn't believe that there are a lot of providers, people around the world speculating jumping into the 5G spectrum auction and getting into that field because it seems attractive to them. Why? Because it resolves some of the last mile access problems. It provides an instant, subscriber access. If you drop a high-speed modem into a user, into a residence, or into an enterprise customer, you don't need to worry about whether that user has a DSL or a fiber or a cable or any other connection. You can get potentially a high-speed connection into the user by just dropping in a modem in their house or in their premises. So it resolves some of those last mile challenges, and that's why fixed mobile broadband, that's the term that people use, is a very attractive service option based on 5G for a lot of providers. Then, of course, because of the low latency capability, because of massive scale and machine type communications, new services are possible through these enhanced use cases for 5G. And then some of the deployment models lend us to deploy better edge compute capability with 5G, and which means, again, better user experiences overall. However, one thing that's true, though, is it does require huge investment in terms of the infrastructure in the RAN space. And from a mass scale perspective, we're probably still 18, 24 months away. Phones are beginning to be announced, or user equipment is beginning to be announced now, with availability sometime later next year. So then you can see some spotty deployments coming up. How long did it take for transition from 3G to LTE? Think about that. How long will it take us to transition from LTE to 5G? We can all speculate in terms of how much it takes and how much investment they'll do. Again, just because this is a use case centric, I wanted to kind of point out that you can take these specialized use cases, applications, database requirements, all of those things, and categorize them into these three broad categories of 5G with enhanced mobile broadband, machine type communication or low latency communication. And then you will see that how, each application, each service or each application falls can be categorized into one of these three buckets and then deployed from a telco perspective. I don't want to go into the details of how vRAN works and how vRAN works for LTE or 5G, but what I want to do is give you a pictorial view of where that compute nodes are deployed in the infrastructure and what is becoming a candidate for containerization going forward. So if you take the 5G architecture, you're splitting the functionality that was in baseband unit, probably running as a virtualized baseband unit, into what we call as centralized and distributed nodes. These centralized and distributed nodes are certainly candidates where you can run these containers. You can run these code in containers. Today, in CUs, they are virtual machines. In terms of any of the trials and any of the conversations we've been having internally, we showed that at the Open Networking Summit in Amsterdam as a demo POC. But there is a lot of talk and there's a lot of conversation around how this implementations can move to containers pretty fast. Not only that, with these infrastructure components moving to containers, there is this standard compute nodes that are being deployed right next to those locations. What we highlight in this picture as edge compute right here inside these two red circles. That edge compute is your generic, compute infrastructure running your traditional applications. It could be, a caching node. It could be your traditional, localized database. It could be your traditional IT application, which could be something that does data analytics with the data that's coming back on this particular infrastructure right there locally rather than at a core data center. Especially that edge compute node allows you to now shunt locally traffic with 5G, where you place the user plane function over there. And then you can do a whole lot of things with different kinds of services and experiment with that. So these compute node infrastructure will have to then run any application, which means containers, VMs alike, right? And those things translate to now many different requirements on our side. So this is about the RAN side. If you look at the packet core for mobile, packet core has evolved from physical devices in the top left side corner to virtualized capability being deployed in OpenStack, which is widely done today, to the new paradigm which is being discussed right now in terms of or being deployed right now, which is CUPS, which is controlled data plane separation for better flexibility, to the top right corner, to the NG core specification, which is the next generation core for 5G, which is potentially all containerized. And all of these functions run in containers. And the very next slide, actually, I'll skip this slide, gives you a picture. This is courtesy of Firm Networks. This is their slide. And when they presented this, they said, imagine that we are taking these 5G core functions and containerizing them, building a microservices model, and here's how we are thinking about refactoring those. There is a set of core components or there is a set of common microservices that we will use across many different components inside our network functions. Fault management, logging, HTTP, licensing, security, registry, right? In-memory replication, MongoDB, ActiveMQ, different types of plugins for network, like Calico plugin. So these are microservices that are already available as part of a commercial catalog. These microservices are common to then all they need to worry about is how do you leverage these microservices, and then how do you build the core functionality that's required by the 5G components like access management function or session management function, which is AMF, SMF stuff, so the service-specific microservices. And then they can have a set of common networking, routing services and protocol load balancing microservices as well that leverages this. So now what was previously packaged all together as a single virtual machine or a set of virtual machines as part of VNF is now completely refactored and broken into all of these microservices. And then these microservices need to be managed as a cluster, as a group, and then deployed in these various different thousands of locations that we need to do. So that brings me to my, the last few slides, which is, so containerizing these things puts in a lot of requirements on, the infrastructure, whether it's so Kubernetes as a container management capability needs to be aware of certain things. Then how do you bring about the other functionality through custom resources, through CRDs, through custom controllers, through service mesh and network mesh, through what other things that we need to be able to add to bring about the similar functionality that we have become a little bit used to in the VM world at the moment, or VM or virtual machine world, and bring that now to the container. So multi-site is incredibly important with respect to edge. So provisioning of those multi-sites, provisioning of those remote nodes, the zero-touch models, the single pane of glass of orchestrator model in terms of how do you place that functionality and where. So stuff that was discussed earlier on the call by Intel in terms of node feature discovery, what Feng just answered, these type of features become incredibly important. Identity and security management, confederation capability, because now you have thousands of these sites, they need to work together as a single cluster. You need to have a common identity across all of those clusters. Common way of orchestrating, managing those. HA models. Do we need a Kubernetes master node on each one of those sites? Do we need some sort of a headless operation pod model on those sites? When you restart these containers, can you restart a single container? If you remember my previous slide in terms of how a single VNF got refactored into all of these different microservices, maybe you need to restart differently in terms of bundles and dependency trees. How do you create those dependency trees and worry about restartability of those application bundles? Multi-tenancy is incredibly important for telco. Often we ignore multi-tenancy because we are typically looking at deploying containers inside a single enterprise. In the telco space, now you're talking about taking a service that needs to be offered to thousands of subscribers, thousands of businesses, and you cannot have an application that shares data for those different subscribers. So you may have copies of applications running, in different tenants. Then those tenants need to get their own view of what's going on from their application perspective, from their infrastructure perspective. Networking requirements, I think there's already been talked about enough. There's more in the context of not just Multus, but also things like native v6. Native v6 everywhere. No NATing, no v4 to v6 conversions. That becomes really, really important. Then data plane acceleration, compute, in terms of real-time capabilities, thread pinning, CPU pinning models. I think Intel did go through some of those things that are coming down. How do you patch OSs? Can you actually worry about dealing with this as a black box approach versus an incremental patching model? If you have 1 million nodes, how can you do incremental patching across those 1 million nodes? And on and on and on, right? I mean, I can keep going on with respect to these set of requirements. Some of these things are being worked. Some of these things are yet to be worked. I think through this community, what I'm interested in is collaborating, working, defining, refining these set of things so that not only when, different groups of people who are involved in this get the right set of things to go, then build and develop both in the community level and at Red Hat level, and participate in that. So that's kind of a quick summary of where things are with respect to edge and containers. Again, it was to provide a quick high-level view, and it's about time as well.
Well,
So,
that That's great. Is there any questions right now? Is someone piping in there with a question?
Yeah, this is Kural actually. So in one of the slide you mentioned about IPv6, right? So in this use case, you're looking for a kind of a dual stack support for both IPv4 and IPv6 in Kubernetes. That
So
kind of model.
actually both. People are looking for dual stack as well as people are looking for just native v6 across the board, no dual stack. So if you go to Japan and you want to talk to any of the telcos in Japan, they'll say, give me everything native v6. Today, there's no more v4 addresses being allocated by IANA. Done.
So they're just saying only IPv6. Okay,
Yep.
that's interesting. Okay.
Yep. Some of the cable cos are also saying the same thing. One of the cable co I was talking to, big, large cable co, right? They're saying, no, we just don't want to bother about this anymore.
Okay. So we
All
also
public addresses, no natting models too. That's the other thing.
Okay, because we seen one of the customers asking for both same in 5G use case, so both IPv4 and IPv6. That's what I was thinking. Like when you say native IPv6, I want to just understand how this customer is looking forward. I mean, if one customer say they will say IPv4 and both IPv6, right? So that's what I want to clearly understand where is the industry is heading towards. Okay.
Yep.
Are there any other questions? I know we've run over time a little bit, but I really wanted to thank you for giving the presentation. It really kind of helped set the stage for all of the other topics that we're going to need to talk about over the next year or so as things develop.